Hey, we're going to review for your test that is Friday. There's a Google form with these questions. I'm going to do many of the questions with you. And then you can input your answers for them and the rest of the ones that you may need to finish on your own. So the first question says, look at the function that is graphed below. What is the greatest rate of increase for this function? So where do you see that this graph increases? Well, I see it increases right here, and right here. The greatest rate of increase, the greatest rate of change, or your slope for those. Which one is the biggest? Well, this one I rise up 1 and right 1. 1 over 1 is 1. This one I rise up 1, 2, 3, 4, and I run right 2, which reduces to 2. So far that's the biggest. This one I go up 1, 2, 3 for my rise, and my run I go right 1, 2, 3, 4, 5. So which is the greatest? This one right here, and you can kind of tell, think about these all as hills. What hill would you rather, or what hill would be the hardest for you to go up? And it would be this one right here. So the greatest rate of increase would be 2. The number of people, N, so number of people is N, who will attend a dance depends on the admission price, which is P, in dollars. This relationship is represented by the equation shown below. N equals 800 minus 50P. Which of these is a correct interpretation of the slope of this equation? Remember, usually your slope is your coefficient in front of your variable. Well, my coefficient in front of my variable here would be that. So minus 50. So technically that 800 has nothing to do with the slope. So those two answers that have an 800, they're out of here. Let's look at the two that I have left. So always be smart about process of elimination when it's multiple choice. 50 people will attend if the admission price is free. Well, if the price is free, that means P would be 0. If I put P in as 0, I'd get 800 minus 0, which equals 800. N is my number of people, so if the admission price was free, and my number of people would be 800. Well, that's out of there, because that's not true. 50 fewer people will attend for every dollar the admission price increases. So let's say I know that if the admission price is 0, 800 people would attend. Okay. What about if I put the price as 1? That would be 800 minus 50 times 1, which is what? 800 minus 50? And 800 minus 50 is 750. So the number of people who would attend if it was $1 would be 750. 50 fewer people will attend for every dollar the admission price increases. Well, I went from 800 people if it was free to 750 if it was $1. So that is true. That was question number 2. Use the graph below. Determine which line on the graph has a slope of 5/3. I got a lot of lines here. Okay, so let's find 2 points on every line and see which one has a slope of 5/3. So this top line right here looks to me like that slope is 1 over 1. So L1 is out of there. Where's L2? Let's use some colors here. L2 crosses right here and right here. So if I go up 1, 2, 3, 4, 5, and right 1, 2, 3, I get the slope I want. So it's line 2. I'm going to check the other lines just to make sure, to refresh your memory in case. Line 3 looks to me like it doesn't cross exactly at a y-intercept that's a positive or a whole number, so I'm going to put a dot there and a dot here. So line 3 goes up 3 and right 1, 2, 3, 4, 5. So that's the opposite of what I wanted. Line 4 crosses right here and right here. It goes up 1, right 2. So line 4 is a slope of 1/2. So that's how those are out of there. All right, question 4. The graph below models the value of a piece of construction equipment as it depreciates over 10 years. Depreciates over 10 years. What was the original value of the piece of construction equipment? If something depreciates, the value goes down. So think about this. I have a negative slope, so that's showing the value is going down. My years is on the x-axis. My value in thousands of dollars is on the y. So at 0 years, it cost $200,000. 1 year, looks like it comes down a little. After 10 years, the value of this item is $0. What was the original value of the piece of construction equipment? So after 0 years, it was $200,000. Well, that means 0 years means it hasn't been bought, hasn't been used, so the original price was $200,000. $100,000 would be over here somewhere, which is like maybe 6 years. $20,000 is way down here somewhere, which would be like, I don't know, somewhere between 9 and 10. And 10,000 obviously is even lower than that. All right, question 5. The graph below shows how the depth of a submarine varied with time during a voyage. Which line segment represents the least rate of change in depth? The least rate of change. So it looks like here's my line segment for R. Here's my line segment for S. Here's my line segment for, I can't tell what that letter is, T. And here's my line segment for U. I can tell right away. So think about it. I want the least rate of change. The least. Remember, the steeper the line, the bigger your rate of change. So this is going up like, is it counting by 200s? So it looks like to me like it's counting by 200. So this goes all the way up to 2,000. This is R. And it goes over, the X is counting by 5. So 5, 10, 15, 20, 25. If I check that rate of change, let me grab my calculator. If I check that rate of change, it is 2,000 divided by 25. It is 80. All right, so for S starts at 2,000 and it goes up, so 200, goes up 200, goes up 400, and it only goes over 5. So 400 divided by 5 is 80. T goes up to 400 and it goes over 510. So line T is 400 divided by 10, which is 40. Line U looks to me like it starts, goes up 2. Let me erase this here because I'm having trouble seeing. It goes up, So you got to be careful here because it looks like line U starts between 28 and 3,000. So it looks like it starts 29. So I got 100. 200 is 300 and another 100 because it's halfway. So that's 400 divided by 5, 10, 15, 20 would be 20. So which one of these has the least rate of change? It would be U. Whoops. And you could kind of tell, remember, the less steep, the less rate of change. The more steep, the higher rate of change or the higher slope. So could you possibly have figured this out without solving it all? You could have. Question 6, compare the two linear functions listed below and determine which equation represents a greater rate of change. All right, so I'm given an equation here in the second function. Think about this, in the second function, my rate of change, or my slope, is 3, and my y-intercept is 7. I'm not given an equation for this one. I'm going to make it so I can identify everything. It crosses the y-axis at, it looks like 7, and the slope is up 2 over 1. So the slope is 2 over 1, and the y-intercept is 7. The greater rate of change would be function 2. Number 7, the table shows the relationship between the number of hours h that John has been hiking and the total distance he has traveled in kilometers. So here's John. After 0 hours, he's 0 distance, makes sense. After 1 hour, he's 4 kilometers. 2 hours, he's 8 kilometers, and so on. Here's Sarah's graph. The graph shows the distance Sarah went over time. So obviously 0 hours, she traveled 0. H is on, so hours is here from the x-axis. And distance, because the d is there. After 1 hour, Sarah has traveled 5 kilometers. After 2 hours, Sarah has traveled 10 kilometers. After 3, she's traveled 15. And after 4, she's traveled 20. I'm assuming the question is, I don't see the question here unless I forgot to copy the question, but I'm assuming the question is, who travels, whose rate of change is higher? Sarah, John's, they hike at the same rate, or there's not enough information? Well, I certainly have enough information. Do they hike at the same rate? After 1 hour, John hiked 4 miles, or 4 kilometers. After 1 hour, she hiked 5. Sarah has the greater rate of change, or the greater slope. Because John's, if I went ahead and graphed John's would be right here. 1 would be about there. 2 is about 8. So he'd be right below her. 3 is about 12. And 4 is about 16. 5 is about 20. So he would be just right below her. Whoops, if I drew a better straight line and actually included that point, he would be right below her. So Sarah's rate of change is better. Alicia and Melissa did jumping jacks. The table below shows the number of jumping jacks that Alicia had done in different amounts of time. So let's look at Alicia. In 1 minute, she did 30. In 2 minutes, she did 60. So every minute, how many jumping jacks is she doing? She's doing 30, so my slope is 30 here. Now let's look at, who is this below? Melissa. All right, so let's find Melissa's rate of change. So it looks to me like another point I have right up here. So I go up 100, and I rise, and I run right, and it's counting by ones, 1, 2, 3, 4. And that reduces to what, 20? So that means every minute, y'all, hopefully you caught me, because 100 divided by 4, isn't that 25? I'm looking at this like, what the heck's going on here? So Melissa did 25 jumping jacks every single minute, okay? Whereas Alicia did 30. So did Melissa do 6 more jumping jacks than Alicia? No. Did Alicia do 6 more than Melissa? No. Did Melissa down here do 5 more than Alicia? Nope. So it's got to be the last one. Alicia did 5 more than Melissa did. Use the 2 functions below to answer the question. So I'm given an equation right here. I should be able to tell that my slope is 1/4 and my y-intercept is -2/3. Here I'm given a table. Which statement about the slopes of the function is true? I know the slope here. Well, go to your calculator. Like, be smart about this. That calculator does a lot. Let's put my table into my calculator. I'm going to go back to my graphing. I'm going to put that table in. So do the plus sign, add a table. I'm going to do it from here. So I got 2, 4, 6, 8, -8, -9, -10, -11. All right, here are my points. Now, just keep in mind, my graph looks like it's counting by twos. I want it to count by ones because it's going 2, 4, 6, 8, 10. I want it to count by ones. So now it's counting by ones on all axes. All right, so if I were to find my slope here, I can tell it decreases, so it's got to be a negative. I go down 1 and right 2. So my slope of this table, down is negative and right is positive. So now that I use that to help, the slopes are both positive. That's not true. This slope is positive, this slope is negative. The slopes are both negative, not true. The slope of function A is positive and function B is negative. I'm thinking that's it. The slope of function A is negative and B is positive. Not true. So the third option is our answer. Question 10. The table shows how much water was in a swimming pool as it was being filled. If you were to use the data to make a graph, what's the slope? You're filling a swimming pool, so it is increasing. So I know it should be positive, which I have all positive answers here, but now I need to go find the actual slope. Well, let's put it in our calculator. Don't work smarter, not harder. All right, I'm going to put them in. All right, so 40, 52. I gotta make this bigger for one sec to make sure I see those numbers. Yeah, 64 and 76. All right, so just keep in mind these numbers are really high, so I'm probably gonna have to scroll way, way up. There's one. Ah, there's another. Now keep in mind, my graph is counting by ones, so I'm going up 5, 10, 11, 12. So I'm rising up 12. And I'm running right 1, 2, 3. 12 divided by 3 is 4. If you didn't want to use your calculator, remember, all of these are points. You could pick 2 points and do y2 minus y1 over x2 minus x1. I'm going to pick the first 2 points. What is that? 10, 40, and 13, 52. Remember, this one would be my x1, y1. This would be my x2, y2. Whoops. So y2 is 52, y1 is 40, x2 is 13, x1 is 10. And then from there, I could use the scientific graphing calculator or scientific calculator portion, make my fraction, see what it reduces to for me. Whoops. 13 minus 10, and it reduces to 4. So either way, I get my answer of 4. All right, number 11. We're getting close to the end here. The graph below shows the increase in average gasoline prices from January through May. And you can see it increases, a positive slope there. If gasoline prices continue to increase at the same rate, what will the average gasoline price be in July of that same year? So May, this would be June, and then July would be after it, right? All right, so in January, the price is how much? Well, it's right between 160 and 180, so it looks to me like it's 170. In March, it's 180. Now keep in mind, from January to March, that's 2 months. So I'm going up 10 cents, and I'm going right 2 months. So each month, it's going up 5 cents. Let's make sure that is true for the next one. So it goes up 10 cents over 2 months. April, what would April be? Well, it goes up 5 cents every month. 180 is here. April is like halfway between 180 and 190. That'd be 185. So if May is 190, June would be 195, and July would be $2. So you got to really think about my months. Yes, it's doing every month, but it wasn't hitting every month here when I went to find my slope, which that helped me figure that out. And I had to realize that on my y-axis, it's counting by, after it does this little jump, it's counting by 10 cents every slot there. So be cautious of that. All right, number 12. All right, Noel is a computer repairman. To fix a computer, he charges $40 per hour plus a fixed fee of $15. So here's my equation. 40 per hour, that means X equals my hours, plus that $15 service fee. What is represented by the variable X? Well, it said 40 per hour. If the variable is with the 40 per hour, that means that's my hours. So the number of hours that Noel worked. The fixed fee for the service call is my y-intercept, my 15. The amount Noel charged per hour is the $40, so not the X part. The total cost of the repair job would be the Y, once I figure out how many hours. So that's all out of there, and A is my option. All right, there are 19 total questions. I have done 12 with you. You guys are going to do 13 to 19 on your own and submit that.